The topic we'll be discussing in this session is optimizations. Consider this scenario. Japanese and a German were meeting at a conference located in Hawaii. Both of them want to use their laptops for exchanging data. Okay. And and they are and they are using mobile IP for mobility support. The Japanese and the German and these two guys were meeting in a conference at Hawaii, and they are using their laptop and they want to exchange some data, and the laptop is running mobile IP with mobility support. Okay, so that means the laptop is something like a mobile device, mobile phone. If the Japanese now sends a packet to this German person, actually the packet will travel from the packet will travel will from his computer to the HA of the German. Okay, that is to the home agent of the German. That is, the packet will travel from Hawaii to German. Okay, then the HA in the German, it will now encapsulate the packet and it will tunnel it to the COA of the German person's laptop. Okay, the HA, the home agent of the German, will now tunnel the packet to the care of address of the German's laptop, which is on Hawaii. So it means the packet is, both of them are in Hawaii and they are sitting in the same room and they are sharing the same table, but the packet is going from Hawaii to German, and again from German it is coming to Hawaii. Okay, so so this means that although the computers or the laptop might be only few meters away, the packets have to travel all around the world. So this inefficient behavior of a mobile IP is called as triangular routing problem. This inefficient behavior of mobile IP is called as triangular routing problem. Okay. The same thing happens when Japanese guy want to communicate with uh, with the same thing will happen when the German guy want to communicate with the Japanese guy. Okay. Again, the packet will go to Japan's HA, and from there it will come to the COA uh, of the of, of the Japan's laptop, which is in Hawaii. Okay, so basically this problem is called as triangular routing. Uh, so with the basic mobile IP protocol, all packets to the particular mobile node have to go through the HA. Okay, and this causes unnecessary overheads on the current location of the mobile node. Okay, and it increases the latency, very much. Okay, so this is particularly a problem if the mobile node and the HAs are separated by a large distance. Okay. So optimize this is one way to optimize this is the CN can one way to optimize the route is to inform the CN about the current location of the MN. Inform the CN about the CN is the correspondent node. Whichever the node which is trying to communicate with the mobile node is called a CN. So inform the CN about the current location of the mobile node. So the CN can learn the current location of the mobile node by catching it in a binding catch. By catching it in a binding catch, which is a part of the local routing table for the CN. Okay. So in this particular lecture, we'll be discussing how these communications between CN and MN can be optimized, especially in such cases when the mobile node is moving from one uh, one foreign agent to another foreign agent. Okay, so we'll be using four types of messages. So this is called as, so what we are discussing here is optimized mobile IP. So this optimized mobile IP will use four type of additional messages. These are binding request, binding update, binding acknowledgement, and binding warning. This particular concept, which is optimized mobile IP. So why we are optimizing, in the sense to overcome the triangular routing problem. This optimized mobile IP, it uses four types of messages. These messages are binding request, binding update, binding acknowledgement, and binding warning. Okay. So let us see what all these things are. Binding request. Binding request means if any node want to know the current location of a mobile node, then it can send a binding request to the HA, that is the home agent. If any node, if they want to know the current location of a mobile node, then it can send a binding request to the HA, that is the home agent. The HA can check if the mobile node has allowed the dissemination of its current location. Then the HA will check whether the mobile node has permitted to share its current location information or not. If the HA is allowed to reveal the location, then the location information will be sent to the node whichever requesting the data. Okay, so this is about binding request. Binding request means any node can request the current location of the MN mobile node by placing a binding request to the HA, home agent. The home agent will check whether MN is permitting to reveal this information or not. If MN is permitting to reveal this information, then that information will be sent to the node which requires the current location of the mobile node. Okay, fine. Next is binding update. What is binding update? So, this is basically the response to the binding request. This is basically the response to the binding request. Whenever a binding request comes, the HA checks whether the current location of the MN can be revealed or not. If the current location can be revealed, then the uh, if the current location can be revealed, then the HA home agent will respond with the binding update. Okay, then the HA, that is home agent, will respond with a binding update. So this binding update will include the fixed IP address of the mobile node and also its COA, care of address. Okay, so binding update is nothing but it is a reply to binding request. Whenever a binding request comes from any node to the HA, the home agent will check whether this information can be revealed or not. If it can be revealed, then it will respond with a binding update. And this binding update includes the fixed IP address of the mobile node and also the its COA, the care of address. Okay, so that is binding update. Next is binding acknowledgement. Next is binding acknowledgement. Okay, so what is binding? So it is binding acknowledgement. Sorry. Okay, so what is binding acknowledgement? So if a node request when a node request a binding request to HA for a particular mobile node, the mobile node will respond with a binding update. Okay. After receiving the binding update, this particular node will respond with a binding acknowledgement, which means I have received your binding information. Okay. So we can I can just draw a diagram for better understanding. So let us assume there are two nodes. One is the CN correspondent node, and here is the HA. Okay, so HA contains information about the mobile node wherever it goes, whether it is in the same HA or it in some other foreign agent. Everything it is available. So CN will first request the HA about the mobile node's current location through what? Through binding request. So let me call it as BR. Through binding request, CN will request the current location of a particular mobile node. And if the location can be revealed, then HA will respond with a binding update. So this binding update will include the mobile node's fixed IP address, and also it will include the COA, care of address. So the HA responds with a binding update. After receiving the binding update, the correspondent node again will respond with a binding acknowledgement. Okay, so let us call it as BA or binding acknowledgement. Okay, so this is the flow, communication flow. That is what we are discussing. Okay, fine. Then the fourth type of message is binding warning. The fourth type of message is binding warning. Okay, what is binding warning? So this is little tricky. So let me explain. Assume that a particular mobile node, okay, currently, initially the mobile node will belong to all mobile nodes belong to a particular home network, and there will be a home agent. It is registered to that home agent. Okay, say that after some time, this particular mobile node has moved to some other network, and it is now registered with a particular no particular some other foreign agent. Okay, the mobile node has moved to a foreign network, and it has moved and it has registered under a foreign agent. Okay, so no more this mobile node is in the current location. Okay, okay, let us assume that there is a node CN, correspondent node. There is a CN. Let us assume this particular CN, it knows the current location of the M1. It knows the current location of the M1. Or say, or let us even consider like this. Say that this CN at this point of time, say this CN at this point of time, it want to communicate with the mobile node. Okay. Now the mobile node where it is, the CN does not know. So first it will place a binding request to HN. HA. It is not, yeah, it is. So in the home network, there will be HA. Okay. So it will place a binding request to the HA, and as a result of that, the HA will respond with a binding update. Okay, which includes the current location of the particular mobile node, and then the CN will obviously will respond with the binding acknowledgement. Okay, now the CN knows the current location of the HA. Sorry, MN mobile node. Now the CN knows the current location of that particular mobile node. Okay. Okay. So now if it wants to communicate with the mobile node, it can communicate. But assume that at this point of time, this mobile node has again moved to some other network. This mobile node has again moved to some other network, and it has registered under some other foreign agent. So the mobile node is no more with the old foreign agent. So we will call this as old foreign agent, and this is new foreign agent. So now the mobile node is not with the old foreign agent, it is registered with the new foreign agent. So it is not here. Okay. But this information is not updated to CN. Because CN has not made any request now to HA. Sometimes back it made a request and it identified that mobile node is with this particular FA, that is old FA. Okay. Now if CN wants to communicate any data, Now if CN wants to communicate any data, what it will do in the sense, it will directly send that to old FA. It will directly send that data to old FA because CA thinks that this particular mobile node is with old FA. So it will send the data to FA old. It will send the data to FA old. But once the data is received by FA old, now FA old, so this is actually tunneled. The data is sent through the tunnel, so it is encapsulated. So FA old will first decapsulate the data. It will decapsulate and it will find that this data is for the a particular mobile node is the destination. So now FA old knows that no more this mobile node is uh, under this network. It is in some other network. Okay. So FA old actually knows it is in which network because that information will be given by MN. When the mobile node moves from one foreign agent to another foreign agent, it will update the previous foreign agent, like in which foreign agent it is now connected. Okay. So now the FA old knows where the mobile node is. So what the FA old will do in the sense, it will forward that packet to mobile node. Okay. Whatever the data it is received from the CN, it will just forward, uh, sorry, it will not forward to the mobile node. It will forward to the FA. It will forward to the new FA. It will forward that data to the new FA. Okay. Okay, it will forward that data to the new FA because FA node knows that now mobile node is connected with new FA, right? And also FA old will send an binding warning to CN, and also FA old will send a binding warning to the correspondent node. Okay, so whenever the correspondent node receives the binding warning, then the correspondent node will understand that it is not communicating with the correct FA. It is communicating with some wrong FA. The moment CN knows this, CN will again send binding request to HA. CN will again send binding request to HA, requesting for, once again it will request for the current location of MN. Okay, and HA will respond with binding update, and with that binding update it will know the current location of the mobile node. Okay, so for this purpose binding warning is used, right? So binding warning is when it is used in the sense, if a node decapsulates the packet for a mobile node, but if it is not the current FA for this MN, so that is FA old we discussed. When FA old decapsulates the packet for a particular mobile node, and if this node is not the FA for the mobile node currently, then it will send a warning message. Uh, then it will send a warning message to the correspondent node, and this warning message is called as binding warning. So that CN can communicate with the HA and get the correct location of the mobile node. Okay. So whenever the mobile node moves, it will just inform the FA old, and also it will register to HA. All movement will be registered with HA. Okay. And it will just inform the previous FA, right? So this is how this binding warning works. Okay. So I think it's clear. So whenever an FA foreign agent decapsulates a packet and finds that the destination node is not in this particular network, then the foreign agent will send a binding warning to the correspondent node, and that message is called as binding warning message. Okay, fine. Now let us discuss a timing diagram which shows how the FA is changing from how the mobile node is changing from one FA to another FA, and how these informations were coordinated between HA and old FA. Okay. So whenever there is a change of FA, packets on the fly during the change can be lost. Whenever there is the mobile node is changing from one FA one foreign agent to another foreign agent, during that time, whatever the packets that were transmitted for the particular mobile node can get lost. There is a possibility. Okay. So to avoid that, what happens in the sense new FA always inform the old FA to avoid packet loss. Okay. Because if there is any packet is received by old FA, then the old FA should send it to new FA. Okay. Old FA now forward the remaining packets to new FA. Old FA now forward the remaining packets to new FA. Okay. This information also enables the old FA to release the resources for the mobile node. Okay. So this happens whenever the mobile node changes from one FA to another FA. And also HA informs the sender about the current location of the mobile node. But HA will not inform automatically. The sender should ask through a binding request. Okay. So if the sender places a binding request, then the HA will inform the sender about the location of the mobile node. Now sender learns the current location of the mobile node and it will redirect the tunneling to that particular location. So let us see this with a timing diagram. Okay. See this mobile node, it is currently registered with FA old. It is currently registered with FA old. Okay. And this information is known to HA. Okay. Because every information about a mobile node, where it will be always registered in HA, the home agent. Okay. Now a correspondent node CN want to communicate with this mobile node. So first it will send a binding request to the HA. It will send a binding request. Here it is not shown, but it sends. But it sends a binding request to the HA. Okay. So then the HA will check whether the location information of the mobile node can be revealed or not. If it can be revealed, then the HA will respond with a binding update. This is binding update. Okay. So with the binding update will include the mobile node's fixed IP address and also its COA. Okay. So its COA normally it will be the FA. FA will be the COA, care of address, the IP address of FA. Okay. After receiving the binding update, the CN will respond with a binding acknowledgement. Okay. So now the correspondent node knows where the mobile node is, and also it knows its COA. So let us assume the COA is FA. There are two types of COA as we discussed. The COA can be in the FA or it can be co-located. That is, in that co-located means it will be in the mobile node itself. So here let us assume the COA is in the FA. So now CN correspondent node knows the location of the mobile node. So now if it wants to send any data, it just sends the data directly to FA old. It sends the data directly to FA old. Okay, because to FA old only the mobile node is registered, and FA old will forward the packet to the mobile node. Okay, because FA old is nothing but COA, so that CN sends that to FA old, and FA old forwards the packet to the mobile node. Fine. Now consider this scenario. Now assume that meanwhile mobile node has moved from FA old to FA new. Mobile node has moved from FA old to FA new. That is, no more the mobile node is with FA old. After this point of time, FA old, the mobile node has moved from FA new to FA old. FA old to FA new. Now it is with FA new. Okay, right? And during the movement, what happens in the sense, the mobile node registers with FA new. Through this registration message, the mobile node now registers with FA new. Once it registers with FA new will update this to FA old. Once the mobile node registers with FA new will update this to FA old. That it will say that this particular mobile node, which is registered under U, now it is no more registered under U, it is registered under FA new. Okay, and for that FA old will acknowledge. For that, FA old also will send an acknowledgement to FA new. Okay. Now, if CN wants to send any data, but CN does not know about this change. But CN does not know anything about this change. Okay. So now if CN wants to send any data, it will just send to FA old. It will just send the data to FA old. But FA old knows that now now the particular mobile node is not with FA old, it is with FA new. So it will forward the packet to FA new. And from there the packet will be forwarded to the mobile node. Okay. But in turn, but in turn, FA old will also send a warning signal, that is binding warning, to CN. But in turn, FA old will also send a binding warning to CN, that is correspondent node. Okay. And for that, the correspondent node will respond with a uh, for that the so once after receiving the warning, the correspondent node will send a binding request to HA. So this line represents HA. Okay. So the correspondent node will send a binding request to HA. Now HA will provide the binding update which contains the current location of the M1, and for that the CN will send an acknowledgement. Okay. So this is how the whole scenario works, right? Okay. Here one more thing. See this first line, what it represents means initially CN wants to communicate with mobile node. Okay. But CN don't know where the mobile node is. The correspondent node don't know where the mobile node is. So here it is not sending the binding request. So generally all node will be by default, it should be with the home agent. Unless and otherwise it is moving, it should be with the home agent. So assuming that the mobile node is in the home agent, CN is sending the data to the home agent. Because home agent will be the COA. Home agent will be the COA generally for any node. Okay. So the correspondent node sends the packet to the home agent. Now the home agent knows that the mobile node is not in the home network, whereas it is in a foreign network. So it sends the data to that particular COA, which is nothing but FA old. And from there the data reaches the mobile node. Okay. But after doing this, home agent also sends the binding update to the CN. In this case, it is sending the binding update even though CN has not asked for it. Because CN is thinking the mobile node is in the COA, so it is sending to COA. It is sending to home agent. Okay. So home agent understands that CN does not know this. So it is sending an update, binding update to CN, which includes the current location of the M1, its IP address and its COA. For that, CN responds with the acknowledgement. Okay. Now again, when CN wants to communicate with M1 second time, now it is not it is not sending to HA. Now it is directly sending to FA old. Okay. Right. So there are two ways. Either the CN can request the HA about the current location of the M1 by sending a binding request and then ask it, or it can just send the data to HA and HA will forward. After forwarding the data, HA will obviously reply back with a binding update to CN so that CN can know the current location of the particular mobile node. Okay. So this is how mobile IP is optimized. Okay. So this is how mobile IP is optimized, and through this optimization, what happens in the sense the triangular routing problem is solved. So basically, this is done by using three types of messages, which are binding request, binding update, binding acknowledgement, and binding warning. Right. So, so I think the concept is clear. Okay. But still, there are some disadvantages with this optimization technique. These are this optimization for mobile IP to avoid triangular routing. It causes several security issues. It causes several security issues. Like there is a security problem called tunnel hijacking. There is a security problem called tunnel hijacking. And another issue is not all users want to reveal their current location. Not all users want to reveal their current location. Here, whenever a mobile node moves from one home network to another network or one foreign network to another foreign network, they should reveal their location so that somebody else can communicate. But in reality, users don't always want to reveal their location. So these are the disadvantage of this optimized mobile IP, right? So let us stop here. Thank you.